Yes, sir.
Okay. Yeah, that's good. Just hold on, I'm starting my whiteboard. Can you see my whiteboard?
Yes, sir. Yes, sir.
Okay, and I hope my audio is right. Okay. Okay, so let's start. So how far did we discuss? So till now we are discussing on the we are trying to think of the compiler as a black box, and we are discussing on the point what compilers are supposed to do, right? Is it? Yes or no?
Yes.
Yes. So we are trying to think what compilers are supposed to do, and only when we can have a good visualization of what compilers are supposed to do, then we'll go into the details that what it is supposed to do, how it does it, right? So what it is supposed to do is what I mean by considering the compiler as a black box. I input source code and I get assembly as output, right? And I for now I consider assembly as the target code, right? For now, the output. And we have also seen in the whole picture. The whole picture. This is just a very short recollection. The whole picture was then the assembler was there. It takes assembly as input and it generates object code, and then you have the loader and linker and loader, and ultimately you generate the executable and load the executable for running, right? Exe and run. So this is how this was the full picture, right? And we are now concentrating on this part from the last class, as I can see from my board work, that compiler is a black box and you give source code, and we are trying to find out what this black box is supposed to do. And in the last classes we were discussing on certain statements, very simple one, and so the left hand side was the input to the black box, and the right hand side of this line was the expected output, right? So we try to think that what exactly is the compiler supposed to do. So if you give this type of expression as one line of source code, what should it generate, right? And it should generate something like this. If you give this as the source code, what should it generate? It should generate something like this. We try to discuss on certain statements. Now, I would have a plan to continue this discussion before unboxing this black box. Maybe in the next class, I will unbox this black box, and we'll try to discuss that now we know what the black box is supposed to do, and from the next class we'll start studying how it does, right? And how it does will give us a picture of the working principle of the compiler. We'll break down this box and try to find out what are the essential components of a compiler, exactly as what are the essential components of the whole scene, right? Now we'll magnify this and try to find out what are the essential components of this black box from the next class. So let us continue the discussion that we have been doing from the previous class. So in the previous class we talked about simple statements, right? So simple statements, and we talked about assignment statements.
Yes, sir.
And we talked about arithmetic statements also, right? So what are the other types of lines of source code? One is obviously simple statements. That includes assignment statements, arithmetic statements. What is another very important type? Can you say? Then you can start. What is another very important type that we should be able to visualize? There are so many things, but yeah, tell me.
If
Sir,
condition
input
Flow
out.
of control. Yeah, flow of control, right? Now, this is input output. Whatever we are discussing is input output only. See, whatever we are discussing is input output only, right? We are trying to visualize for a specific input, what should be the output from the compiler black box? We have not yet unveiled the black box, right? So we are trying to discuss that, okay, if this is the input, for example, if this is the input, what should be the output? And we found out that this is the output, right? This is the output. This should go this side. I wrote it on this side. It should go this side, right? So this is the input and this is the output of the compiler, expected output, right? Now remember, this output is raw output. There are many things that we should be studying on this output pattern. For example, this was the output of the previous statement. So can you say what special things the compiler needs to do on the output? Obviously, it should optimize code, right? It should optimize the output, right? It should optimize the assembly such that in the later phases, the code looks compact and the code looks efficient, right? This was just a touch. Okay, let us come back. So what I am asking is, other than assignment statements, other than arithmetic statements, what is the next most important thing that you encountered while programming? Yes? Flow of control, right? Yes? I want to hear a yes from everybody. I don't like a class where people don't talk to me. So assignment statements, arithmetic statements, and flow of control. These three are three most important things, right? Agreed? Yes or no?
Yes, sir.
And whatever you say, somebody was trying to say input output. I think he was trying to convey printf sort of things, printf and scanf sort of things, right? Now those are not part of the logical discussion that we are doing right now, right? Those are part of library functions and system calls, more complex things. Now I am asking you, I am talking about simple statements so that we can visualize things, so that we can try to understand what the black box is supposed to do. So if we make that the input is a simple line of code. Now generally the input is not a single line of code, right? Generally the input is a bunch of lines of code, right? And the output is also a huge assembly file that I have already shown you by compiling a very simple program to print out the value of pi, sin pi. So such a simple program with only one line of executable, the value printing the value of sin pi by 2. Such a huge assembly code and such a huge object code was generated, right? So without complicating things, I'm just talking about simple things, a single statement at a time. If we input to the black box, what output we expect. And this discussion that I'm doing from the last two classes is for two things. One is so that you can get a whole picture of the compiler, rather than teaching compiler from directly going to the blocks of the compiler. I'm trying to give you the whole picture, right? That would make more sense. And another reason is, or whatever discussions that I am doing is based on the fact that you have already studied system software and assembly coding, right? So things should become interesting to you. Things should become more visualizable to you. You can see things. So let us come to flow of control. Okay. So let me think of. Okay. So flow of control. I can say. Let us talk about logical statements. Logical. Okay. Flow of control in fact means logical condition checking, right? Let us think about this. And what is the first thing that comes in your mind is the if statement, right? Yes or no? Yes, yeah. So okay, let us talk about the if first. Very good. Then we will go to if then else, right? Okay.
So
I will include, yeah. Yes?
Your mic is sounding a little muffled, sir.
Little muffled? Okay, okay, okay. Let me, yeah. So why don't you tell me? You
Actually,
should be installed.
it was adjustable till a few minutes ago, sir. Suddenly it got a bit too distorted, sir.
Okay, just tell me. Okay. Now, is it okay? Is it okay?
So
Hello?
slightly, sir. So slightly, sir, but not. It's still
Now
a
is
little.
it okay? Now is it okay?
Yes, sir.
Is it okay?
Yes,
Yeah?
sir.
Is it better? Yeah. Okay. So the decibel was raised. I don't know why, but I think it is by default. So I decrease the decibel so that echoing is controlled. So there is no echo right now, right?
No, sir.
Yes, sir.
Okay. Okay. Thank you. So let us start with the very simple if statement. So how does it look like? It looks like well, let me structureize things. If say A equal to B, then you do something. Then you do something in C. And if I structureize, let us algorithmically say there is something called endif also, so that we can aid things. Do you agree with this, or I will not write endif? So if I write endif, things would look more structured, or otherwise you can just go with if A equal to B, then do something, right? Yes or no? Now, what should be the expected output of the compiler? This was the input portion. What should be the expected output of the compiler? Yes. So for example, the output is assembly. So you should be looking for some assembly instruction to compare A and B, right? So
Compare.
generally it is CMP. Yes or no? You have done all these things. So I will compare A and B, right?
Yes, sir.
Then if A is equal to B, I should be doing these. And if A is not equal to B, I should be looking for endif, right? That's why I have written endif. Now this is more Pascal-like code, right? Did you hear of the programming language Pascal? Yes or no?
Yes, sir.
Heard of it.
Yeah. But this is more C-like. So let us deal with this. So if I compare A and B, if they are equal, then I intend to perform these statements, and if they are not equal, I want to terminate this conditional evaluation and go out, right? So what should be done? So what should be done? In assembly, the thing is just opposite. Do you remember branch not zero? B and Z instruction. Similarly, you can think of an instruction called branch not equal. So you compare A and B. If they are not equal, I go to some label for end. I should look for a label for end, right? And then I go for label for end colon, and then I exit. And if branch not equal is false, then I actually do these statements. Convincing? Yes or no? Now I mean to say that the compiler, the black box that is sitting in between, that is supposed to do this, convert this source to this assembly, has to work on the fact that I have to invert this logic. Here the logic was if A is equal to B, then I will do such things and then simply exit. Here I compare A and B, and then if not equal, then I set a label. Now if you remember the .s codes, there were labels in your code, right? Okay, now let me write it in a proper fashion so that things become more clear to you. Let me put some indenting there. So it is CMP AB Now branch not equal, where to go? There is a label for end, right? It's a label I have created to end, right? And then this is label for end colon, and there you should be calling the instruction for exit. I just do not remember what should be the instruction for exit, but you should be calling the instruction for exit. And if branch not equal is, if it is true, then go to end, right? If it is not equal, go to end. If it is equal, then do the statements, these statements. These are the then statements. Now if you remember your .s file, you had such labels, right? Yes or no? Let me show you.
Yes.
I think I have them. Yes, I think I have them. Yes, did you see the labels? These are the labels. Do you remember? These are the labels in your .s file, right? Similarly, that is what I mean. So an assembly generally works with labels. There are go-tos and jumps. Do you remember the basic structure? So these are the labels, and there are go-tos and there are jumps. That is how it works. So similarly, I have created a label that indicates that that is the end of the program. And what I will do is I will call something called branch not equal. If it is not equal, if A and B is not equal, then I will go to that label for end. If it is equal, then I will process the statements. This is just inverted logic. Can you recognize the logic is inverted?
Yes, sir.
Yes. So the compiler, the black box that sits in between the input and the expected output, needs to call appropriate, it needs to convert this code to appropriate instructions of assembly with appropriate mnemonics such that the logic is preserved via inverted logic. That is the key lesson that I want to give you. Everybody convinced? Yes.
So I didn't understand, why is it inverted
Understand.
logic?
It is inverted logic. See, it is inverted logic because in assembly you have instructions like branch not equal. You don't have instructions like branch equal. If you go to assembly, because assembly depends on jumps to labels, so you create a label and you say that, okay, I have created a label called label for end, and here I defined how to end the program, right? So let me write it in a bigger font. So what I mean is, in assembly, what you do is you work with labels. So you start with comparing A and B. If A and B are equal, what to do? That you don't have an instruction in assembly. Generally, you have instructions like to compare if they are not equal. Now, if you try to ask me why assembly have those things, then I need a full class to explain. That I am trying to avoid. Just for now, try to remember. In assembly, you did learn some instructions like branch not equal to 0, right? Yes or no? Branch not equal. It means this instruction will branch to branch not equal. You compare, and if they are not equal, then you have branch not equal. That means you jump to, this instruction means branch to a label underscore for ending the program. Right? I'm just writing this. Now I define this label for ending the program. And then I call the appropriate counterpart of exiting the program. Let it be capital EXIT, right? And then if not equal is not true, that means if it is true, if they are true, then perform these statements, write those statements. So if these statements are normal statements, the compiler has to convert these statements to appropriate assembly and put it here, right? That is what I mean. So let us not try to think about what are these statements. Let these be statements that we discussed in the last class. So these are the then statements. Got my point?
Yes, sir.
So in assembly, actually you have instructions that do a lot of go-tos and jumps, right? So now you have two questions. One is why assembly doesn't have branch equal? Why it relies more on branch not equal? Now for this answer I need a class on assembly that I'm trying to avoid right now. So what I'm saying is just try to recollect that you studied something like branch not zero, branch not equal sort of stuff, right, in the previous semesters. And I'm just using that. I'm comparing A, B. If they are not equal, then I am straightforwardly jumping to a label. So I have created a label. And that label is label for ending the program. I have named it like that. And that label contains the exit code of the program. Right? Just now I cannot recollect what should be the exit. I think it is capital exit only. Let us check. Okay, what should be the exit code? See, this is end proc, CFI end proc. This is a block that ends the program. So for x86 64-bit, it is CFI end proc. So for example, to simplify things, in a theoretical class, let it be exit, right? So I have created a label. If they are not equal, I will straightforward jump to that label and exit. And if they are equal, so I am not explicitly using any instruction to say whether they are equal or not. I am inverting the logic and defining a label for not equal and going to that label if they are not equal, if the comparison fails. But if they are equal, then I am executing this stuff in this section. Does it make sense? Yes or no? Because if you say, then only can I proceed.
Yes, sir.
Okay. So reversing logic. So let us think logically. Reversing logic. What are the sorts of reversing logic? You can have less than. The opposite is greater than equal to. So if you have branch. Now let you have instruction called branch less than. So the opposite is branch greater than equal, right? If you have branch less than equal, then you have to invert the logic of branch greater than. If it is branch equal, and then you have branch not equal. Now here I took the question of somebody asked me why we can't have, if I go to that question, why we can't have something like branch less than, branch equal. Now let that we have these instructions. So in assembly what simplifies is, even if you have this sort of instruction, without going for checking this, we are going to check the inverted ones. Why? There is a logic. The logic is, if there are two chances, right, that they are equal or they are not equal. If they are not equal, then I should be able to jump to a label. So this gives me an opportunity to define a label, because assembly works it works based on labels, and since it works based on labels and it makes multiple jumps, assembly code is faster in nature, right? Do you know all these things? Yes or no? Yes or no?
Sir, it will be the same case if we give the branch equal command also, no, sir. It is the same way.
A branch what? What?
I'm
Branch
saying
equal?
it will be the same way if we use branch equal
If
command
you,
also.
okay. If you give branch equal, what is the meaning of branch equal? Do you need a branch equal? So if compare, see, you are creating a logic. Come on. So let me answer your question. So you are telling me branch equal, right? So you are telling me to define something like branch equal. Branch equal. Yes, where to go? Label. Label what? Label for equal, right? I have named it label for equal. Okay, so let it be label for equal. Now label for equal starts with a statement number 1 and it may have multiple statements. Now do you want to continue statement after statement with say after statement 1 you say continue. After statement 2, you have to write continue. After statement 3, you have to write continue. After statement 4, you have to write continue. After statement 5, you have to write continue. Or even if you don't write continue, if you say that, okay, my assembly language program by default means if I have a bunch of statements, all the statements will be dealt with one after another. Now tell me your logic. Branch equal, is it required? If you check for comparison and if it is equal, if A is equal to B, do you require something called branch equal? If A is equal to B, then you can straightforwardly write if A is equal to B, so compare AB, you are saying that if A is equal to B, I will straightforwardly write these statements, right? Write these statements. Now what if A is not equal to B? Who will deal with that? Let me write it down here. Okay. So what did I say just now, 5 minutes back? In assembly, it is easier to work with inverted logic in a sense that assembly looks for labels to jump and that makes the code run faster. Try to visualize. Now you are comparing C and P, A, B. There are two options. They may be equal, they may not be equal. If they are equal, your code should look like compare A, B, then you put the bunch of lines and then you call exit. Right? If they are not equal, you have C and P, A, B. If they are not equal, you exit. You should not be doing all these things because they are not equal. So where is the control in your code? How to control that checking whether the output of compare AB is equal or whether it is not equal? How to control? Now you may say that I will control with, I am coming to your question. You may say that I will control with branch equal. So I put branch equal because here I have let that A is equal to B. In this tree I have let maybe equal, A is equal to B. So if compare of A is equal to B is true, then branch equal and you do all such things and then exit, right? And on the right hand side you say that if they are not equal, compare AB is not equal, exit. So now my question is, so putting a branch equal still doesn't put a control on this portion of code, no control. Very separate looking codes for the control checking. So branch equal makes no sense. Got my point? Yes or no?
Yes, sir.
Yes, sir.
So compare AB, you have two possibilities. One is equal, I repeat, one is equal, they may be equal, and one is they may be not equal. If they are equal, you are saying that I will put branch equal. I will not go to branch not equal. Okay, I take your logic. I put branch equal. If I put branch equal and put the statements under that label, I will say that what is the need of this statement? If they are equal, as of this handle of the tree, I am coming to this handle of this tree because they are equal. So I will compare. Always I will get an equal, and so I will execute these statements. Why do I need a branch equal? Do I need a branch equal? I do not need, right? And if they are not equal, I will straightforwardly exit. So I do not need a branch equal or a branch not equal. So so what you get is you get two different code sections for two different possibilities. One possibility is they are equal, one possibility is they are not equal. What I am saying is I will combine these two possibilities in one code. I will combine these two possibilities in only one code by introducing something called an inverted logic, other than using some branch equal, because branch equal is not required at all. Branch equal gives you no cognitive value, right? You cannot just have a single piece of code with this logic. Your code is divided into two portions. Yes or no? So I go with branch not equal. And what I do is I put this portion of code, that means I put the exit section in a label, and I put that if it is not equal, go to that label. Otherwise, no need to go to that label, do the stuff. So what I mean is, you can, what you will say is CNP AB branch not equal label for exit. So if they are not equal, go to a label for exit, right? So I implemented the right hand side with right hand side of this code option with this line of code, branch not equal label exit, and then I put the stuff. This is the main portion, right? So if branch not equal is not true, then I will do all such things. But if branch not equal is true, that means that's really not equal, I will go to that label, exit. I'll call exit. This is a code that has more cognitive value in terms that this code is also able to take a decision what to do. If they are not equal, I exit. If they are equal, I do the stuff. But this code, if you do not implement with branch not equal, for example, the inverted logic, if you go with something called branch equal, even if you use branch equal, it is not solving the problem, because it is not solving the problem. It is just same as writing branch equal or branch, it is same as writing branch equal or not writing branch equal. Got my point? For example, if you write the code like this, this code will not be able to compare. So compare A, B, branch equal, then branch equal, go to a label for them, right? That is what you are saying. Then you create a label, then do the stuff, and then exit. Now this is your code with the non-inverted logic. This is your code with the logic not inverted. So compare AB, branch equal, label for them, then you do such things and then exit. Where is the portion to deal with if they are not same? Tell me. Do your code have the section to give you a decision that if they are not equal, what to do? Are you saying that, you are saying if they are equal, what to do? You are going for a label for them, this is the label for them, and you have the stuff here. But where are you telling the machine what to do if they are not equal? Tell me. Are you telling? Yes or no?
No, sir.
Yes. So I hope that solves the problem, right? Yes or no? So that's why assembly is fond of inverted logic. Now, if you want me to go into further details, I need extra class. If you give me an extra class, I will go into further details of how the stack segments look and how it works. So let us not complicate things. So you are agreed, everybody agreed. I want to listen a yes from everybody. Yes?
Yes, sir.
Yes, sir.
Okay. Yeah. So let us list down the opposites. So if you have a less than checking in your source code, I am writing SC for source code. If you have a less than checking in your source code, I will just use branch greater than or equal to for this, right? If you have a less than equal to in your source code, then I will just use branch greater than, because that is giving me more edge, more cognitive value to the code, right? I have the control. And if you have equal, for example, if you have branch equal, then in your assembly, what I will do is I will just invert branch not equal. See, I am talking about very simple things. You should be able to recollect and think logically, okay? Okay, so okay, so let us take an example of if then else. So let me write C code. If A is greater than B, do some stuff, else do some other stuff, right? Now this is a source code. Okay. So what should be? So we'll go for a compare A B. Then it is greater than, right? So I'll invert the logic. Branch less than, equal. It is greater than, so its opposite is less than or equal. So let it be BLE. I don't know what exactly it will be for your x86 architecture. I have given you the documents, I have given you the manuals. It is your responsibility to find it out. Okay? So let BLE be something like branch less than equal. Then I create a label for else. I create a label for the else portion, right? This portion. And then I define this label for else, and I put this stuff here. Done. I put another label for end because I need to end somewhere. And if branch less than equal is false, that means if it is really greater, this is true, then I should be able to this set of statements. Let it be S1, this is S2. So this is S2. I have inverted the logic. So I put the S1 here. The bunch of statements S1 for them. And after I finish, I will just blindly jump to a label because there is no logic for creating a label. This is a logical creation of jumping, right? If less than equal, don't jump. But here I will do a blind jump because my work is complete. With the last statement of this S1, my work is complete. So I will just jump to label for end. And I have defined label for end with an exit code. Does it make sense? Yes or no? Check and tell me. This is what the compiler is expected to do. Yes or no?
Yes, sir.
1 second. It's reading
Okay.
through it.
Is my handwriting okay?
Yes, sir. Yes, sir.
Okay. Yes, tell me, where is your problem?
Yes, I understood.
Understood?
Yes.
Yes, sir.
Okay. So can you just try and write a sample assembly for me? I give you a code with values of variables. Just little assignment. Don't waste time. Just try honestly, right? Because honesty is the biggest virtue that you have. So I give you a piece of code. If say A is less than 8, B is equal to 3, and C is equal to 4, else else E is equal to 5 and F is equal to 9. I've given you this code. Now convert this. Think of yourself as the compiler, the black box. And I expect some output from the black box. That is, I expect an output from you. Okay? Just tell me what to do.
Sir, CMP A8.
Yes?
Sir, CMP A8.
CMP A8?
Yes, sir.
A8? Okay.
Yes, sir.
Yes. Okay.
Something like
So
CMP
after that-
immediate.
I'll give you, I want the complete code. Let that you put A in register R1, you put B in register, say, let us make things arbitrary, okay, in R4, C in register R5, E in register R6, and F in register R7. Now tell me, for example, don't just say me that CMP A8, you just write CMP, sorry, I'm doing the same thing. CMP A is in R1, for example, R1, 8.
Okay, sir.
Complete the code like this, okay?
Okay, sir.
Okay, yeah. So just before you write the code, this is the job of this black box only to find out in which registers these values reside, right? And exactly here comes the role of interaction of the compiler, the black box, with the different functionalities of the system, for example, the operating system. Right? Because that's how registers are allocated. Okay. Complete it, and do you have some place to write so that you can share the screen? Do you have any input device like stylus or something to write? Anybody?
Really, sir.
You don't have, right? Okay. CMP R18. Then
So BGE else.
very good, very good. Let there be something called branch greater than equal. Very good. Yes. Then BGE.
Else.
Label for
Okay. Label for else.
Yeah.
Label for else. Okay. So let us talk about the label for else here. Label for else. Okay. Label for else. What should be done? So in label for else, you are moving the value 5 to E. So it should be move 5 R6. Right? Yeah, it should be, the next should be move 7 R7. Right?
the 9.
Okay. Huh?
So
So
9
nine.
Oh, sorry.
No, 9 R7.
Yeah. 9 R7. Yeah. Yeah, I wrote a 7 here also. Okay. So branch greater than, then create this label and jump to this label, right? So that gives you the control of the two options of this comparison. They may be less than, they may be greater than or equal. And then we put this stuff here, right? What is this stuff? Move, yes,
So
3,
move 3 to R4.
R4, very good. Then move
The move 4 to R5.
4 to R5, very good. Then a blind jump, because I
Jump
don't
for
need any logic. Yeah, jump for,
Jump
yeah,
for
label,
exit.
label for end. And I create a label for end, very good. And label for end,
Sir, exit.
exit, yeah. Right? Now it is your job to find out what this particular assembly instruction is for exiting your code. For your x86 64-bit Intel architecture, I have given you your everything. You should find out what should be the real BGE instruction for your architecture. Right? What should your jump look like? What should your CMP look like? I'm just talking in a very, in a very theoretical way. Okay, conceptual way. Okay, what next? While loop? Yes, let us just deal with while loop, because in while loop you have the option to think about breaking from a loop or continuing the loop, right? Break and continue. You remember all these things? Okay, that could be a good example. To end today's class, what is the time? Actually, I'm a bit tired today. It is 6:10. Okay, let us take example of while. And with today's class, the viewing your compiler as a black box will end, right? So what we have studied till now, we have studied compilers as a system software. Where does it fit in the whole system? So it fits in such a way that it comes before the assembler, and then after the assembler comes the linker, and then comes the loader. We had already 2 elaborate classes on this, and I have given you pointers to study more. So we have studied the bigger picture where the compiler black box fits in your system. And then we are trying to think what is expected from your black box. So in the left I am writing some source code, and in the right the expected output of the assembler, right? Now from the next class we will try to think that in real case we will not have a single line of source code. In real case we will not have a for, right? In real case we will not have a if. We will have a bunch of such statements and big programs. The compiler should compile all the statements, bind all the statements together, resolve all the conflicts, and assign values from statement 1 to statement 100, do all such stuff to actually end up in the right hand side, to actually end up in the right hand side like this, right? And that is what we are going to start from next day. So today let us just think of another very interesting thing, while. So let us think of while. Let's say x is greater than 0. Do some stuff, right? Yes or no? Let me write the proper C code. Okay, so how it should be done?
Or assuming that X is in register R1,
Yeah,
so we could write CMP R1, comma 0,
yeah, very
and
good.
see that BLE and if it's BLE, then exit, label for exit,
Right.
and
Then
otherwise
code for the while loop body, right? And then jump to
yes, sir.
yeah. So yeah. So it is solved by my students. Done. I'm not repeating things. I'm saving time. Okay. So let us think about while with a break, right? So while, I'm just complicating a bit. Nothing. These are very easy things for you. While you have a body, and then if say y is equal to if y is equal to 4, break. Then you have a bunch of statements. What should be done for this?
Inside the while loop, I think we need CMP while, assuming it's in R2, we need CMP R2 comma 4, and if it's not equal, we'll go to label for exit.
Okay, so I have given here greater than. So you are saying that after comparing x with a 0, assuming that x is in some register, let me write proper code. Let it be in R2. So compare R2 with a 0, right? Then the key is inverting this logic. So branch less than equal. This is greater than. So it should be branch less than equal and label for exit. And do the stuff here, and then compare say y is in R3 with 4, then you do what is required here, this bunch, and then do a blind jump to where? Tell me.
To
One
the
second.
CMP statement, to CMP R2
Yes.
comma 0.
Yes,
Yes.
So one
Yes, yes.
question. If R3, if y is equal to 4, we are breaking, right? So in that case, right after R3 4,
One minute. Just let me write down that x is in R1, R2, and y is in R3. Huh? Now tell me, what does a
Sir.
break do? If this
Sir.
logic is true, it breaks from the loop, right?
So in that
If
case,
this logic is true, it breaks from the loop.
yes, sir. So it will be BNE R3 4. Sorry, my bad. So if it's BNE, then it will jump to label exit, sir, again.
Yes, B and E, branch not equal, then branch to label exit. Very good. So I have a label exit, right? Exit. And if this branch not equal is not true, that means if it is equal, then what to do?
So then
Then
execute.
you do this stuff, then do this stuff, right?
Yes, sir.
And after you do this stuff, what to do? You should go back here, right?
Yes, sir.
Yes? So
Yes,
after you
jump.
do this stuff, yeah, there should be a blind jump to what? You should have a label here for
Compare.
this. Yeah, it's loop label, for example. And then what I do is, I name this as loop label. And then write my code. So my code that starts from CMP is inside a loop label. Yes or no?
Yes.
This is, yeah, so this is label also. Now things have started become interesting. So this itself is labeled, right? Yes or no?
Yes, sir.
So compare R20, branch less than, do the stuff, compare R34, branch not equal. If it is not equal, you go to exit. If equal, do the stuff, and then jump back to where? I need a label to jump back, because these jump statements, BLE statements, and all these statements look for labels. So my whole code is a labeled code right now. Let it be loop label. Yes or no?
Yes, sir.
Yes, so the compiler, yes, the compiler, think of yourself as the compiler. The compiler is supposed to, generate code with a label altogether. So for example, your while loop is inside of a big source code of 500 lines. So the compiler should take care of creating those labels, so that you don't have redundant labels and they are marked properly and all these things. So at every time I'm just trying to visualize what the compiler is supposed to do. I'm not trying to do anything else. Yes or no? Yes? Yeah, okay. So shall I continue with? Okay, let us end today's class with do while. This is another important thing. Do while. So how does it look? Do a bunch of statements while something is true, right? So let me write it down. While x is greater than 0, for example. Yes, do while. The code is correct? Yes or no? Do a bunch of statements while x is greater than 0.
Yes, sir.
Okay, so what to do?
So the CMP will be at the end of the label, I think.
Hmm?
The
So
CMP.
will be at the end of the label, sir, and
Yeah.
the content also.
Okay, if I complicate things a bit, um, let me do something like you have a bunch of statements, then you have continue, then you have another bunch of statements. Then what to do? Did you work with continue statement?
Yes.
Yes. Does it look like this? I have written in all caps, just to make you understand. So what does it do? So if the continue statement is not there, then all these statement 1, statement 2, then statement 3, 4, 5 will be executed, and then checked whether x is greater than 0, and then you have this loop. It will go on.
So if the continuous statement is there, statement 1 and statement 2 will be executed, and we'll go to the next iteration, sir.
Yeah, then it will skip this portion, right? 3, 4 and 5. It will skip this portion, it will not execute this portion.
Yes.
So only these two statements, and then we skip this. So that is what I mean, how to skip. How to create labels that skip. So you think yourself as a compiler, what you are supposed to do. So let us create a loop label from the last example, loop label. Let me solve it for you and end today's class. Loop label. Then you have the statements. And then create a continue label. And then but this continue should
Sir, continue will be just, sir, in case
Yeah.
of the continue label, sir, what we need to do is that if the condition is fulfilled, in
Mhm.
that, we just jump back to the loop label again.
Yeah. So continue label we have, after that we have a compare to compare the x, and then if it is 0, so let it be branch less than equal, and then go to loop label, right?
Yes, sir.
Yeah. And we have an exit label. Compare exit label. label for exit, right?
Yes, sir.
So I have shown you how to write code with labels. Done? So this ends. So what did we do for all these days? We studied the whole picture, the bigger picture. Where does your compiler fit in the whole system, right? And we have tried to think what the compiler is supposed to do, right? So from next class we'll investigate, we'll unreveal the black box and find out we'll know what the compiler is supposed to do. We'll start studying how it does, and that is the study of compilers, specifically compiler design. So this includes the study of compilers as a whole. How it works, how it does, is actually compiler design.
Sir, one question, sir.
Yes,
Sir, in case of the last code, sir,
last code, yeah.
Sir, after the continue is done and after we execute statements S3 and S4, sir, after the BLE to the loop label, sir, we have to jump back, right? If the BLE is not.
You have to jump back, yeah. You have to jump back. So continue label should take you to the loop label.
No, sir, I'm telling you after CMP, for example, if X is in R1, so it will be CMP R10 BLE label for end or exit label, and then JMP loop label, right?
Yes. What is the problem?
No, sir, that is, I just needed to confirm that, sir. That's the problem.
So continue label is a label that takes you back to this label, right? So continue means what? Continue means that you should skip these statements and directly go for a compare.
Yes, sir.
So continue label would what it would do, you can do two things. One is you can create a label for compare here, right? So comp label. So continue label will take you to the compare label, right? That means you skip all these things. Now if continue is conditional, for example, if you have, say I write if b is equal to 4, continue. Generally continue is conditional, right? So again, before continue there should be a compare, and then you will have logic for that comparison, and if it is false then go to continue label, and continue label will take you to the comparison label, because here you compare whether x is greater than 0. If it is true, then you go to loop label. Is it clear?
Yes, sir.
So let me write it down properly so that there is no confusion. I don't want to have anyone confused. I want everything to be crystal clear in everybody's brain. So loop label. What? The statements. Code for the body statements, right? Code for the do while body. And then you have a continue label. You straight create another label for comparison of condition. What condition? Of condition for the continue. For example, you have if a is 4, then continue, right? So there is a if. So for that you create a label for condition checking, or you do not require to go to a label for condition checking. You just create a label, and you just create a label and then compare a with 5. For example, you say your code is if a is equal to 5, continue. This is a statement, right? So continue label compare a5, branch not equal, then branch not equal to where? I create a label for comparing x, right? Now you create a label for comparing x, and in that label you compare whether x is 0 or not, and if not equal, then go to loop label, right? Yes or no? And after this compare value for you go to you straight. There is no require for a jump here because it is do while. So you will go to exit level. Yes or no? And the code sample code is do bunch of statements. Then you have if a is equal to 5, continue. Bunch of statements, and then while x is greater than 0, right? So for this code, I have tried to think what the compiler should generate. So you have a loop label. You have a loop label. You start here. You start right here. Loop label. You have a bunch of statements. Then continue label. Now continue doesn't need to go to another label because continue label starts with the comparison. If a is equal to 5, then continue, right? So I straightforwardly compare a and 5. If a is not equal to 5, then I go to the comparison for x. If a is not equal to 5, if a is equal to 5, then I go to compare, right? Whether x is greater than 0 or not. So I go to that level and compare, and then you create branch not equal, and if it is not equal, where to go? Loop level.
So it will be
yes.
BNE, sir, because it's x
Where?
greater than.
BNE, I have written BNE, right? Oh, BLE, yeah, BLE. Yeah. Thank you. BLE. So if it is not so, then I intend to go back here and continue with all this stuff in the same way that I did for the first time. That is do while, right?
Yes, sir.
Okay, so agreed. Right? Everybody agreed?
Yes, sir.
So next class we'll open that box and see what is there inside the compiler. So that ends class today. Okay? Thank you. Yeah.
Thank you, sir.
Thank you,
Thank you,
sir.
Yeah, thank you.